Okay, so welcome to this lesson about modeling real-life phenomena. And I will show you here projectile motion, how that could be described with a quadratic model or second-degree equation. And you can see that I've written down the exercise that I will show you. The questions in the exercises will come later here. So if you would like to start writing this down in your notebook, you take a pause now and then you can get your calculator as well, because I will show you how we can use the calculator to find the answers to the questions I will write down before you. So the question is, or the statement before I ask you the question is this: on Earth, the height h meter above the ground, t seconds after you throw a stone straight upwards, can be described with a function, and this is the function. So if you throw a stone straight upwards, I will show you with my eraser. If you throw it, and this is upwards direction now, it will go upwards and then falls down to the ground. And we can describe it with this equation with three constants. And I will tell you that this constant 2, that is the height above the ground where the stone leaves my hand. 2 meters above the ground. I know that because when the stone leaves my hand, we start the clock. So the time is 0 when it leaves my hand. So when t is 0 over there and over there, these two terms become 0. So h0, the height when the time is 0, will be 2. So that is where it leaves my hand, 2 meters above the ground. Now, 10 is the speed that I throw the stone with. It's 10 meters per second. It has to be meters per second because the height is in meter and the time is in seconds. Oops, and I see that I've misspelled it, seconds. Okay, and it's on Earth, so this has to do with the gravity on Earth. If I have been throwing a stone on the moon, then I would have another constant here. So this is the height in meter above the ground. I throw it straight upwards, the stone is falling down like this. Now, I will look at the graph first, and I will use my calculator. So you take your calculator as well. If I'm talking too fast, now you can take a pause and you can play it back and see it many times as you want to. So, okay, here you see a graph, but I will show you how you will get this graph. So you go into y equals, and then you take clear if you have some other functions instead of y at. And if you have some function on y2, you erase it as well with clear. Now, this is my equation. So I write it on y1. And you start with a negative sign. That's not a subtraction, so don't use that now. It's a negative value. Negative 4.9. And then we have a multiplication sign. I don't need to press multiplication. The calculator understands if I just write an x and then take it to the power of 2. I square it. So you see, I have time here, but my calculator uses x for the time. It's no problem for you. Plus, now I use this sign, this operation, plus 10x and plus 2. Okay, I can start by using the standard window. So I choose zoom and I go down to standard and I press enter. And I got a graph. It looks like this. And I realize we don't have negative times and the stone can't be below ground level. So I will change the window. I do it on window. And x is the time. There is no negative time, so I start when the time is 0. And the stone won't be in the air in 10 seconds. I don't know how long time it will be in the air. So if I don't choose a good times, and I will see it when I draw the graph, then I can go back to window and change this value. But I choose 5. That is 5 seconds, probably too long time for it to be in the air. The scale is 1 second. Why min? Why minimum? Well, it can't be negative values. That should imply that it's below the ground. In this case, it can't be, so I choose 0. The maximum height, 10 meter? Well, it could be. I don't know. The scale and XRES, I'll let it be 1 here. And then I press graph. And then I can see this. It looks like you are throwing a stone to the right. But you know, this is the time axis. So you are throwing the stone straight up and then it falls back again. So this is the time axis, what's happening and what is the height on different times. Okay, so let's investigate this now. And we can start by some facts that we know about this. We have the constant A, B, and C. A is negative 4.9, and B is 10, and C is 2. It's good information to remember that we have. Now, the first question is, use the model to find the maximum height of the ball or the stone. Sorry, well, doesn't say, yes, it was a stone, so of course we should have stone here. Oh, this eraser is not good. So, stone, like this. Well, to find the maximum height, I first need the symmetry line. The symmetry line will give us the maximum height. So I need to find x sim, but in this case it's time instead of x. So t sim is, and then I write it here so we remember x sim, the formula for it is minus b divided with 2a. That's the symmetry line. So in this case, b is 10. So minus 10 divided with 2a. Now we have 2 and a is negative 4.9. Negative 4.9. This is the value for the time where the height is at maximum. So let's use the calculator to find out. Clear? Negative value. Negative. Time divided with brackets 2 times negative 4.9. So the time symmetry is 1.02 and in seconds. Now, the height and the maximum height, let's call it h maximum, is equal to, well, this equation gives me the height, and I will use the time for the symmetry line. That gives me the maximum height, because the symmetry intersects the graph at the maximum height. So, minus 4.9, that is this value. And instead of t, I take the symmetry line's value, multiply it with 1.02, and I square it, because I do in my formula, plus 10 times 1.02. That is this, 10 times 1.02, plus 2. Plus 2. And that will gives us the height in meter and the maximum height. So I use my calculator to find out what it is. Negative 4.9. I multiply it with 1.02, but I'm not supposed to round it off now. You see, there are many decimals. So instead, I take the arrow, I mark this, and I press enter. Then I got all the decimals, and then I take it to the power of 2. Arrow to the right, and I add with 10 times this same value. So I take the arrow up, press enter, and then I have 10 times this time. And then plus 2, the constant at the end. And I press enter. So 7.1. 7.1. That's the maximum height in meter. So, answer 7.1 meter with 2 significant figures here. That's the maximum height of the stone. Okay, the second question here. So, use the model to find the time until it hits the ground. Okay, so first now, before we start, I will do a very fast sketch of the height, and it's how it the connection with the height and the time for it. So we have the time and we have the height. And you saw on the calculator it did look something like this. This is, the value is 2 here. It's the constant. It's the intercept with the y-axis, but now it's the height axis. The time until it hits the ground, that is the time that you find here. This is the time when the stone is at the air. Now, you see, the time when it hits the ground is when the height is 0, because the height is 0 here and all along this axis. So the height that depends on the time has to be 0. So the question is, what time gives us the height 0? Well, the height is described with this equation. So instead of the height, I write negative 4.9 t squared plus 10t plus 2 is equals to 0. The height is the same as this. It should be 0. So we have a second degree equation to solve. And we have the formula for it. So let's use it. The formula tells us that you should take the b value and the negative sign for it, so it's minus 10 plus minus the square root of 10 squared minus 4 times the constant a, that is negative 4.9, times the constant 2, so 2. And then we have to divide with 2 times the constant a, the constant before the second degree term, that is minus 4.9. Okay, so we will have two answers, T1 and T2. Now you can use your calculator to try to calculate this value. So take a pause from this video, do it, and then you start it when you're done and see if you have done it correct. Then I will show you. So let's use the calculator. And when I do this, I will start by calculating this inside the square root. So I start with 10 squared. Well, you don't have to calculate 10 squared with your calculator. That is 100. And then you subtract with 4 times negative 4.9 times 2. That is this part. Enter. And then I will take the square root of it, but it's faster to take it to the power of a half. The square root of something is the same thing as take it to the power of a half. That is this. And then I will take minus 10, and I start with taking negative these values. So now I write minus 10, and then I take minus this value. So I go up and pick it up like this, press enter, and then I divide it with 2 times negative 4.9. So I need a brackets. 2 times negative 4.9. That is 2.22 seconds. Okay, let's do the same thing, but instead I take plus. So I start with negative 10. Negative 10 plus this value, so I have to go up and pick it up. It was 11.79, so I press enter. Then it jumps down like this. Enter. Divide it with this. Divide, brackets, 2 times negative 4.9 is equal to negative 0.18 seconds. Well, how do you interpret this, a negative value? Well, I will show you. The negative values, you have them here. And if you draw this line, we don't have it, but you could. In maths, you can draw the lines like this. Well, this distance, that is a time, is negative 0.18. But this time has to be this value. It takes 2.22 seconds until it reaches the ground again. So, answer. The time until it hits the ground, let's call it t, is equal to 2.22 seconds. Okay, finally, let's see if our calculator can find these values. So, let's do like this. We press graph, and then we see the curve. You have it here, the sketch of it, and with our calculator. And first of all, we want to find the maximum height. And that is a calculation our calculator have to do. So calc with blue. So let's start with press second and calc. And then the maximum. So I go down to 4 and press enter. And then it says left bound. So I need to use the arrows. And let's see if I can find any marker. In here you see this dot. It's going on the curve like this. And this has to be to the left of the maximum, where we think the maximum value is. So left bound, now it's to the left of the value that we want to find. So I press enter. Right bound, now I go to the right of the curve. And there are standing on the right side of the maximum value. And I press enter. Guess, well, if you just have one curve like this, you just press enter. And then it says the maximum height is when x is 1.02. Well, that is our symmetry line. 1.02 in seconds. And the height is then 7.1 meters, just like we got it. And the second question, the time until it hits the ground. That is when the y value is 0. So if I press calc again, second trace, then I have 0 here. That's the y value. So I go one step down and press enter. And then it says left bound again. So I'm standing somewhere like here, and then I press enter. And right bound, now I have to go below the t-axis, or the x-axis in this case. So if I think that the y value is 0 here, then I have to stand somewhere like here and somewhere like here. And then I ask my calculator to find the intercept here with the t-axis. It's not that very clever, so I have to do this. And then it says guess, and I just press enter once more time. And then it says it's 0, and you can see it here. Y is 0 when the time is 2.22 seconds, just like we got it. Okay, thank you.